50-50. Okay, I'm with you guys. I'm with you. Okay, so today, I don't know if you remember us discussing this, but we were going to talk about the basics in calculus, and then I'll obviously do the sort of more difficult calculus questions with you next week, which will be our second to last lesson. So what I wanted to talk about today, because calculus is such a big section, I mean, it's about 40 marks, isn't it? So, you know, this really is something that we have to try and do. Oh, Karabo, I'm sorry. Nelly, can you please explain to Karabo where to access the recordings?
Yes.
Cool. Just send a message. Thank you so much, Nelly. Okay, Karabo, Nelly will message you, okay, and tell you where to find them. All right, so back to calculus being a big section. We know by now that the very first question that we're going to get is going to be on first principles. And the idea behind the first principles question is that this really is a level 2 question. So every single one of us should be able to answer this without too much difficulty. All right, so I know sometimes people do struggle with it a little bit, but it's not meant to be particularly difficult. What I'm going to do is I'm going to work through it with you, and then obviously you guys have got pens, pencils, calculators, all that kind of stuff. You can make notes and write stuff down and take down the questions, etc., etc. So we know that when we see first principles, we've got to go and use our formula. All right, now our formula on our formula sheet tells us f prime x, so the derivative of f with respect to x, is equal to the limit as h tends to 0 of f of x plus h minus f of x all over h. Now, it's really, really important in calculus. It's not just the maths that you are doing. It's also the notation that you are using that's really important. Okay, so I'm sure all of you have looked at memos and had these discussions with your teachers in class. They can and do penalize you for certain things, all right? So the first thing that I want to point out to you here before I actually do the question, right, is number one, don't drop your limit notation until you are ready to do so. Okay, so don't drop limit notation until ready. And I'll explain what I mean when I say until ready. The second thing is that you do not ever show that h is equal to 0. Okay, so do not show that h is equal to 0. Okay, so just some little tips for you when you are answering this particular question. So in your next line down, you will keep your limit notation as h tends to 0. And what I actually do is I don't sub in. I actually go to, I take a page, whatever my page is. So in other words, in this case, I would say f of x plus h. And then what I do is I then go and work out what that would be equal to. So in this case, it's 2x squared minus 5. So this would be 2x plus h squared. Is it minus 5? Let's double check. Yes, minus 5. Like so. Be careful now when you square your binomial, right? Remember, when you square a binomial, it has to have how many terms? When we square a binomial, how many terms are we expecting to get? We want 3 terms, quite right. We want 3 terms. So on the outside, we've got our 2, and here we've got x squared plus 2xh plus h squared. Okay, there I've squared the binomial minus 5. Last thing that we want to do is remove the brackets. So that will give us 2x squared plus 2xh plus h squared minus 5. And none of those are like terms, so they all just have to stay as they are. We know that f of x is equal to 2x squared minus 5. So what I do, and you guys don't have to do this if you don't want to, is I actually then work out what f of x plus h minus f of x is going to be equal to. And then I take that and I go and I sub it in. Faheen, I see you've got a question. What did you want to ask? You're welcome to unmute.
Don't you multiply by simplifying the bracket with the 2 outside? Wasn't supposed to.
Oh, hang on a second. Yes, good, quite right. So this is supposed to be 4 here, isn't it? And it's supposed to be 2 there. Sorry, thank you, Fahid. Thank you for pointing that out. I was just being silly. Sorry, thank you very much. Yes, this was supposed to be 4 and that was supposed to be 2x squared. Thank you, my girl, for looking out for that. Let me just get rid of that because that's not correct. And then that is supposed to be a 4 and that is supposed to be a 2, isn't it? There we go. That's much better. Thank you, Faheen. All right. And now I'm going to subtract 2x squared minus 5. So that will become plus 5. And I change my signs. And now everything that does not have an x in it needs to go. So the 5 is gone. The 2x squared is gone. And what I'm left with is 4xh plus 2h squared. And then I take that and I go and sub it in here. Okay, now there's a bit going on in the chat here. There we go. Okay, all right. So you guys were also just pointing out I've made a mistake. Okay, so we understand how we've gone from this point over here where we worked out what f of x plus h was. We've written down what f of x was, and we have found the difference in terms of x and h. And now we go and we sub it in here. The next step, again, we're not going to drop our limit notation because we're not ready to do so, is to factorize out the h. Now, something that happens with a lot of matrics is that this denominator disappears and then somehow magically reappears somewhere down to the bottom. If you do that, they are going to penalize you. Okay, so make sure that you are writing things in the correct way. In fact, what's probably better for you to do here, don't worry about the amount of paper you use. You can use up a book and then take another book, right? Rather spread things out and make it as easy for the person marking it to see your work as possible. Okay, because they don't know who you are. They don't know that when you wrote a 6, you meant a 0 or whatever the case is. Okay, so spread your work out so that they can read it clearly. Leave lines in between here. Okay, leave lines in between so that you can clearly see what's in your numerator and your denominator. Okay, all right, so you took out the h, and quite right, we are left with 4x plus 2h over h. Now we can cancel. You're supposed to show that. And then this is the important part. Now you are ready to drop your limit notation because you have factorized out the h. Okay, so you will drop the limit notation after you factorized out the h. It is not necessary to show that h is equal to 0. You must not do that. And all you are going to write is equals 4x, just like that. It is indeed. Okay, just 4x. All right, so you can check your answer using the power rule. So 2 times 2 is 4x. Take 1 away from the exponent, and that would leave you with your 4x. And of course, the derivative of any constant would be 0. Okay, and that is how you are supposed to set it out. Okay, everybody happy with that? Are there any questions that you want to ask about what we've just done? Okay, so it's worth 5 marks. That's a lot of marks. There would definitely be marks for that, marks for that, marks for the factorizing. I think there's an accuracy on this line, and then the last mark would be over there on the answer. Okay, so do not make little errors along the way where you, as I say, either drop the limit notation or show that h is equal to 0, or don't set it out in the correct way. Because then you run the risk of being penalized. Okay, and we want every single mark we can possibly get. Okay, you took out 2h. Okay, not necessary, Diana. All you're ever going to do is take out h. You'll only ever take out h. Okay, even if you can take out a factor of 2 as well, you're just taking out the h, because what you want is to get rid of that denominator. Okay, awesome. So pleased. All right, so that was a nice question. We're feeling good, we're feeling confident. Let's go on and have a look at the rest of the questions that are here. Okay, so now when they say to us, use the rules for differentiation, they're telling us we are not supposed to be using first principles anymore. They now want us to use the rules for differentiation. So before we continue, my question to you is, what are the rules for differentiation? What rules for differentiation do you know? Okay, so take the power, times it by the base, subtract 1 by the power. Oh, this is Anik, this is not a government paper. All right, I'm not doing a government paper today because I figured you guys had probably seen all of those before. So this is not a government paper. You won't find this online. Okay, I was trying to expose you to something that you haven't seen before, or at least try to anyway. Okay, no problem. All right, so you know about the power rule, which you've explained really nicely. So we're multiplying the exponent by the coefficient, and then we're taking 1 away from the exponent. Lovely, so that's one of our rules. What's another rule for differentiation? So the first one is our power rule. The derivative of any constant is? What's the derivative of any constant? Always equal to. There we go, Kanisa. It's always equal to 0. Quite right. The other thing that we need to know before we can answer the questions in this section, all right, and these maybe are not so much rules, but it's a way of having to be able to work with all of this information, all right? So there are things that we need to remove if we are given. What do we remove? What 3 things always have to be removed before we can differentiate? Absolutely, Kanise. So we have to get rid of, there we go, lovely. Somebody else said brackets. Good, guys, very nice. So we have to get rid of brackets. We have to get rid of root signs over variables. Okay, root signs on numbers is fine because those are constants, but root signs on variables got to go. And we also have to get rid of divide lines. Quite right. Okay, we've got to get rid of divide lines. We've got to get rid of denominators. Okay, so no denominators. All right. Let's just talk a little bit more about denominators before we carry on. All right. There are 2 kinds of denominators that they can give you. All right. Either they can give you a monomial, or they could give you a binomial. We have to work with these differently. What do we do? No problem. Nelly, will you just change? Thank you. Oh, you're a star, Nelly. Thanks. So what do we do if we have monomial denominators? So in the case of 8.22, there's a monomial denominator. There's 1 term in the denominator. How do I work with that? What am I expected to do? Okay, so what I have to do, what I'm trying to get at here is when you have got a monomial denominator, you have to split your fraction. Okay, so in other words, if you have got 2 plus 3 over 7, you are expected to write it as 2 over 7 plus 3 over 7. That's the first step. Okay, so if you've got a monomial, you're going to split it, right? If you've got a binomial denominator, right, what do we do then? We have to factorize. Okay, absolutely, we have to factorize. So we need to know these things because we've got to have a strategy with which we approach our questions. That's why all of this information is so important. Okay, because we've got to know that when we see a certain thing, there's a certain way of us being able to deal with it. Okay. All right, so that was just a summary of how we would answer these sorts of questions. Let's go back and do the first one. All right. Now, a very common mistake for a lot of students to make is they just write dy over dx, dy over dx, dy over dx, dy over dx. Okay, you can't do that. Right, you can only write dy over dx when you use the power rule. Okay, so in the line of working where you are applying your power rule, that is when you write dy over dx or f prime x, or you drop, like in the case of 8.22, you drop the dx in the square brackets and you write equals, only in that line. Before then, if you are removing your brackets, your roots, and your divide lines, you are not differentiating. You are preparing the function statement for differentiation. So it has to stay as y equals or f of x equals or dx with the square brackets. Are we all good with that? Thumbs up. Is this making sense? You've heard your teacher say this as well. I'm just checking in. Cool. Nice. All right. Okay. Sorry, I don't mean to sound pedantic. It's just that I want you guys to get all the marks you can possibly get, and that's why I'm just trying to be really thorough about this. Okay, so our first step here is to continue to write y equals. And now we are going to multiply out our brackets. So that is going to give us 2x to the power of 5 plus 14x cubed. So that really isn't so bad. Anik, I can repeat that with pleasure. Okay. When matric students learn calculus, they don't really understand what the notation means. So you can be forgiven, certainly in the beginning bits, for writing dy over dx, dy over dx, dy over dx in every line of working, right? But that's not the correct thing to do. So it is only when you apply your power rule that you change your notation from y to dy over dx, or f of x to f prime x. So if you have a look here, Anik, it was a function statement in terms of y. I've kept it as a function statement in terms of y. I'm not differentiating. All I'm doing when I went from this line of working to this line of working is I removed brackets. I didn't differentiate. So that's why I'm not writing dy over dx, because I'm not ready to. Okay, so in calculus, it's not just about what you wrote, but the way in which you wrote it as well. Okay, which is what I was trying to say at the beginning. So now that we have removed the brackets, oh, okay, all right, you've got it. Okay. Now we are ready to differentiate. Remember, we are only going to apply our power rule when every single term has been written in the same way. We need to see the coefficient, we need to have the variable in the numerator, and we need to have an appropriate exponent, okay, on every single term. Otherwise, we cannot apply our power rule. Here we can see our coefficients, all our variables are in the numerator. We can see what our exponents are. So we're ready to go. Okay, so dy over dx, quite right. The derivative of y with respect to x is, as Spoo so beautifully put there for us, 10x to the power of 4. Well done, Spoo. plus, what was the rest of your answer? I'm copying it down. 42x squared. Lovely. Okay, very, very nice. Okay, now it makes sense why this is out of 3 marks. 1 mark for removing the brackets and a consistent accuracy on each of those terms. Okay, so make sure that you get those marks. Is everybody happy with that? Is that making sense? Good stuff. Lovely. Thanks, Itumeleng. I'm glad. All right, now let's do 8.22. All right, so a slightly more difficult question, but something that we should still all theoretically be able to do. Again, we are not ready to derive, right? We're not ready to derive because we see 2 things that we're not allowed to have. What are those 2 things that we see in question 8.22 that we have to remove? What needs to go? Absolutely. Okay, the square root needs to go, the denominator needs to go, 100% the root needs to go. All right, that's exactly it. Okay, so no denominator and no root. When we have a monomial denominator, what do? We split up our fraction. Okay, but here we're going to have to split and do something else. All right, because this is just a little bit more complicated. So it's up to you how you want to do it. You can split first and then deal with a fraction, or you can actually, I think what I would do is this, all right? I'm going to split it up, but I'm going to write 5x squared over, and instead of writing root x, I'm going to get rid of my root sign. So now I'm going to write it to the power of 1 over 2. That's it. Minus 3 over x to the power of a half. Right, so now what I've done is I've killed 2 birds with 1 stone, as they say in English, because I have got rid of my root and I've also split it up. Can you see I'm keeping my notation? I'm not dropping my notation because I'm not ready to differentiate. In my next line, I can write equals dx. And now what I want to do, and this is really grade 8 work, so that should make you guys feel really confident. Now what I want to do is I want to write the term so that I've got my coefficient, my variable in the numerator, and my exponent. So from grade 8, when we divide like bases, what happens to our exponents? What happens to exponents when we divide like bases? Exactly, we subtract them. Quite right. Quite right, we subtract them. Okay, so you're going to say 2 minus a half, aren't you? And you're going to write this as 5x to the power of what? Good, yes, we subtract. So 5x to the power of what, Matrix? That's it, Diana. Good job. Okay, so 1.5, guys, or 3 over 2. Lovely, Kanisa. Good, Valencia. Perfect. Okay, and then we're going to do the same thing on this side if it's possible, but it's not possible because we don't have an x in the expression. So now what we've got to do here is we've got to take that variable from the denominator into the numerator. When we take the variable from the denominator into the numerator, what do we do to the sign of the exponent? It's got to, yeah, it's going to become negative. Okay, it's going to change, quite right, Kanisa, from being positive to being negative. So we will write 3x to the power of minus 1 over 2. Okay, so can you see again? I'm not, yes, Fahim, quite right, it's going to become negative. Okay, I'm not squashing my work up. I'm leaving lines in between. I can clearly see what's in the numerator and what's in the denominator. So make sure that you spread your work out as much as possible. Okay, are we ready to apply the power rule? Have we got coefficient, variable, and numerator with appropriate exponent? We do. Okay, yes, we do. Okay, so now that we're in this situation, now we are ready to differentiate. So when it comes to this sort of notation, all right, when it comes to this sort of notation, we drop the dx and the square bracket. That is exactly the same. It means the same thing as writing dy over dx or f prime x. So the square bracket and the dx are going to go away. Then you are signaling to the person marking your work, you are applying the power rule. So now, and you're welcome to use your calculators for this if you don't feel confident to do it on your own, you are going to multiply 5 by 3 over 2. So the coefficient of the first term of our derivative is going to be what? Coefficient of the first term of our derivative will be? That's it. Okay. 15 over 2. Okay, and in Tumeling, it's going to be positive because 3 over 2 is positive and 5 is positive. Okay, so it's a positive times a positive, which gives us a positive. But I'm glad you're thinking about signs because the next one is not going to be negative. All right, x, and then what's the exponent going to be on your variable? So it's going to be 15 over 2x to the power of, that's okay, my girl. Half, quite right, quite right. All right, so sign, number, variable, stop. Stop, 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 okay? Don't just go and write the next sign straight away because sometimes what happens is a situation like this, where we've got a negative times a negative. All right, so sign, number, variable, stop. Sign, number, variable, stop. Okay, so here a negative times a negative is a positive. All right, 3 times a half would leave us with 3 over 2 x, and then what's the exponent going to be on that second term of our derivative? That's it. Good, Kanisa. Good, Bokomoso. Yes, Diana, we'll talk about it now. Okay, minus 3 over 2, because remember we are taking away 1. So even if you want to do it on your calculator, it's not a problem. Put in the minus half, go minus 1 equals, and then there's your exponent. Okay. That's it. Okay, you figured it out. All right, no problem, Diana. That's it. That's exactly what we did. Okay, now that one's out of 4, a little bit more work. All right, so the one thing that we do know for sure is that there will be consistent accuracies on our answer. So that's where at least 2 of our marks are going. Then here, I think that there would probably be a mark, don't think for splitting, but I think for writing root x is x to the power of half. And I think here it would be for some sort of simplification. All right, so simplifying your, so maybe either or, simplifying either the one on the left or the one on the right. Okay, Ntebogang, go for it. You're welcome to unmute and ask, Ntebogang.
Ma'am.
Hello.
Hi. Since x is to the power of a negative, should we not take it underneath, like to the denominator, so it can be positive?
You know, in Ntebogang, in matric, you don't have to do that. Okay, so don't even worry about it. And it's strange, isn't it? Because ever since grade 9, where you first learned about this, they would make you do that. But in matric, you are allowed to leave your answers with negative exponents.
Okay, thank you.
Okay, no problem. Okay, all right. Everybody good with that? How are you feeling? You guys okay? Pilo, I see you also had a question. Did you want to ask something, Pilo? It's Boho. Go for it.
Hi, ma'am.
Hi, Pilo.
Ma'am, I have a question, ma'am.
Go for it.
In the second step, ma'am, I'm confused how we got -1/2.
Okay. Are you talking about this over here that I've just highlighted in yellow?
Yes.
Okay. All right. So if you look at the line above, can you see that I had my divide line and I had my base in the denominator? So what I've done from line number 1 going down to line number 2 is I've taken the base out of the denominator and I've put it into the numerator. And I've used my negative exponent law. So I don't know if you remember this from whenever, I think it was grade 9, the first time you did it. If you have got something like 1/x to the power of -2, you can write that as x to the power of +2. Okay,
Yes,
or if you have 1/x to the power of -3, sorry, no, let's make it +3. You can write that as x to the power of -3. Okay, so what happens is that we write the reciprocal. So in other words, what was in the denominator is in the numerator, and we change the sign of the exponent.
I see. Okay, no, I understand, ma'am.
All right, okay, with pleasure, no problem. I know somebody else had a question. Let's just see. Okay. Teko, how did you get 3x to the -1/2? Okay, so it was exactly what I've just explained to Pilo. Okay, so it's that taking that base from the denominator into the numerator and then changing the sign of the exponent. Okay, that is one of your exponent laws. All right, sorry, I can also see there's other people with hands up. Go for it, Dit Boho.
Ma'am,
Yes, hello.
hi. Can I just ask? I know it's going to be wrong, but are we allowed to derive the numbers inside of the brackets before we multiply?
No. No, you have to do it. You have to do it in the order in which I've shown you. Okay, so yeah, you first have to get rid of the things that need to be got rid of. So in other words, your denominators, your root signs over variables, your brackets, and then you would do it exactly in the same order that I've done it over here. You can't, and then of course when you are deriving, that's when you're dropping your dx and your square brackets so that the person marking your work can see that you've actually applied your power rule. Okay, so the line in which you drop the dx in the square bracket is the line in which you apply the power rule.
Okay.
Okay. Then there's somebody else with a hand up. Mr. Flandorp, did you want to ask something?
Hi, ma'am. I'm
Hi there.
still a bit confused with the last line for the answer.
Okay. Okay.
So I don't fully understand how we got to the answer.
Okay. Do you mean both terms?
Yes, ma'am.
Okay. All right. So when we go from line 2 to line 3, we are applying our power rule, which means that we are multiplying our exponent. Our exponent is 3/2. We are multiplying that with 5. And then what we are doing is that we are taking 1 away from the exponent. So in other words, we've got 3/2, and now we are taking away 1. Okay, that's your power rule. So when you multiply fractions together, you multiply numerator with numerator and denominator with denominator. So 3 times 5 is where the 15 comes from, and 2 times 1 is where the 2 comes from. Put down your x, and when you take 1 away from 3/2, 3/2 is 1.5. So if you take away 1, then you would just be left with a half. Does that make sense? Right, and it would be the same thing with the second term. Okay, Kamchelo, so it's same story here. You have got -3, which you need to multiply by -1/2 because you are multiplying the exponent with a coefficient. Then you're writing down the x, you're taking your -1/2, and then you are taking away 1. So a negative times a negative is a positive, and 3 times a half is 3/2. Write down your x, and then on your calculator, go -1/2, -1, and then you'll get -1.5. And that's where the terms come from. Okay. Oh, good. Oh, good. Oh, goodness. Sorry. Where did I go? Sorry, guys. I clicked on the wrong thing. Okay. There we go. We're back. Okay. It's a pleasure, Kamchelo. Pleasure, Mr. Flandorp. Hopefully, now that you guys understand these things, these are questions that you will be able to access and you will be able to get right. Okay, so I'm really, really hopeful of that for you. Okay, I'm really pleased that you ask questions and participate the way that you do. It's so awesome teaching you guys. All right, let's crack on if there aren't any other questions, and let's talk about question 8.3, which is a fairly sort of common question in calculus. We don't know if they're going to ask something like this at the end of the year, but being able to solve simultaneously is so, so very important. So even if for nothing else, if we just talk about solving simultaneously, it really is worth our while. Okay, so I think what I'm going to do, let me just move this out the way because I'm going to try and do that later. And let's just have a look at question 8.3. So they've told us that we have a straight line. It is the line y equals -7x plus 3, and it is a tangent to f of x. F of x is a parabola because it takes the form ax squared plus bx plus 5 at the point where x is equal to -1. They want us to calculate the values of a and b. All right, so in other words, they want us to calculate the coefficient of the x squared term, and they want us to calculate the coefficient of the x term. Right, so is everybody happy that we are talking about a straight line and a parabola? And we know what the x coordinate is at the point of tangency. All right, lovely. So we understand the information that we've been given. If we want to solve simultaneously, what do we need? If we want to solve for A and B simultaneously, there are two things that we need to be able to do that. What are they? Yes, Diana. They did give us an x coordinate, quite right. We can sub in to get a y value. We can. Kanisa, do we need x and y intercepts in this sort of question? Quite right, Diana. Okay, so this question over here, Kanisa, they're not asking us about x and y intercepts. Right, they're asking us it's a calculus question, right? And they want us to solve simultaneously. So working out the x and y intercepts is not going to get us any marks. So it's like if I say to you, there we go, proud. There we go. That's what I was looking for. Quite right. We need two equations. Okay, we need two equations. We have to have a strategy for answering a question. Right, so we need two equations, both with A and B in them if we want to solve simultaneously. Okay, So now, Diana, how are we going to use the information we've been given to create the two equations? Okay, what's the first thing that we can do? Okay, so when we want to solve simultaneously, we want two equations. How do we make them using the information they have given us? What's the first thing we can do? And someone's already said it.
Ma'am,
Yes, go for it.
sorry, my bed's making a noise. Just correct me if I'm wrong, but you take the -1 and you sub it into y's thingy-mabobby, then I have the coordinate of -1 and 10, and then sub that into, you know what, I'm probably wrong.
No, you're quite right. What you would do with the -1 though is you wouldn't sub it into y, but you would sub it into x.
I know, but I mean like the y equals -7x plus 3, sub it into that one.
Oh,
then you
okay,
get-
okay, sub it into that one and then you've got the y. Yes, quite right. Absolutely.
And then you
I don't
sub
know why
those
you
two
think.
coordinates into
Absolutely.
fx.
Absolutely, absolutely, quite right. Okay, so 100% that's the first thing that you would do. And then the second thing, I see specifically, you've put your answer here. Absolutely, we would work out the derivative. Quite right, Fahim. So we want to sub -1 in. So the first thing that we're going to do is we're going to sub in -1, okay, over here. All right, so 7, oh, sorry, it's -7 times -1 plus 3 is going to give us a y coordinate of 10. All right, so we know the gradient at the point of tangency is -7. We know the x coordinate at the point of tangency is -1, and we know what the y coordinate at the point of tangency is. It is 10, okay? Now we have a coordinate pair, here they are, that we can sub into f of x. So we're going to go ahead and we're going to go and sub that in. So 10 or f of x, y is equal to ax squared plus bx plus 5. Okay, there's us making our first equation. Now let's just tidy up things a little bit. So we've got 10 equals 1a minus b plus 5, and then let's put like terms together. So I'm going to take the 5 over to the other side, subtract it from 10, and we get 5 equals a minus b. Exactly. Okay, so there we go. We've got equation number 1. Right, now we need equation number 2. All right, and this is where Specicle gave us the right answer, okay, and said that we need to work with the derivative. All right, quite right. We need to work with the derivative. So here we are saying f prime x equals 2ax plus b, because I'm applying my power rule. I know what the derivative is because the derivative of f with respect to x is the gradient of the tangent. Okay, and I've got that bit of information up here. So now what I can do is I can sub in my 7, but I need to get rid of that x, or sorry, my -7. So I'm going to sub in that -7, and then here I know that x is equal to -1 at the point of tangency. And here, guys, is equation number 2 starting to emerge. So -7 equals minus 2a plus b. All right, there are our 2 equations that we need in order to be able to solve simultaneously. Now remember, the first one we obtained by subbing x and y into f of x. The second one we obtained by using the derivative. Okay, so the gradient of the tangent, so the number in front of the x is the gradient of your tangent, and that is your derivative at that point. That is your gradient at that point. Okay, and now, however we want to solve simultaneously, we must just go ahead and go and do it. All right, so probably the easiest thing for us to do here is let's make b the subject of the formula. We'll take that 2a over to the other side, so that'll give us positive 2a minus 7. And then what I'm going to do is I'm going to go and sub it back into equation number 1. Okay, so subbing, so this is now, I've made equation number 3 here, and now I'm going to sub 3 into 1. Okay, so I've got 5 equals A minus whatever B is, which is 2A minus 7. Let's just move down and give ourselves a bit of space here. Whoopsie. So that would leave us with 5 equals A minus 2A plus 7. So this means we'd have 5 equals negative A plus 7. I'm going to take the A over to the left, the 5 over to the right, and A is going to be equal to 2 in this case. Now I'm going to use equation number 3 to work out what B is equal to. So B is equal to 2 times 2 minus 7, which is 4 minus 7. So B would be equal to negative 3. Okay. How do you guys feel about that question? Is that making sense? Are there any questions that you want to ask about how we got those answers? Go for it. Isbogo.
I don't quite understand when you said 5 equals 2 minus 8 plus 7.
Which line is that? 5 equals?
5 equals to negative A plus 7.
You mean negative 2A?
No, yeah, after that step.
Okay, so because now what I'm doing here is I'm removing my brackets. So if I remove the brackets and I've got a minus in front, then I have to change the signs of my terms. So 2A has to become negative and negative 7 has to become positive. Yes. Okay. Does that make sense to you now?
Yeah, the following step though.
Okay, all right. So now A minus 2A is negative A. Then what I've done is I've taken, so A minus 2A is negative A. And then I've taken that and I've moved it over to the left-hand side. And now it's positive A. And then I've kept the 7 on the right, and then I've taken the 5 over to the other side, and I've said 7 minus 5 is 2.
I understood.
Do you understand?
Yeah.
Okay, cool. All right. Anybody else got any questions they want to ask? You sure, Matrix? No questions. Go for it, Diana.
Oh, okay, I'm unmuted. Am I allowed to join a grade 11 class and another grade 12 class?
Diana, I actually don't know, to be honest with you. I'm not sure. Maybe Nelly knows, but I don't know.
If you don't mind paying extra.
Yeah, no, I don't. I know. I don't see why not. But I actually don't. I'm not 100% sure of the. I think maybe Nelly might know more about that than I do. Nelly, can you answer?
I'm not sure as well. I think I will ask on the group and then get back to you before the end of the class.
Oh, okay, cool. Thank you.
Yeah. So
No
you want
problem.
to join a grade 11 class?
I want to join a grade 11 class, and then are there any other grade 12 classes?
Yes, there's a grade 12 class after this one.
Another one. You see, I want to join the one after this one too.
Okay. Well, we'll message and we'll find out for you and see what the story is with that. Okay. Yeah, because I'm afraid I must be honest. I don't. Okay, no problem. In Kateko, yes. 5 minus 7 is negative A, and then divide both sides by -1 to get to correct. Absolutely, 100%. Okay, just a slightly different way of doing it, but all good. Okay, all right, so there we go. We have worked through that question. What I was hoping we might be able to. And Tebogang, do you want to ask a question? Go for it. You're welcome to ask in Tebogang.
Oh, okay, ma'am. So we only introduce the first derivative after like finding the answer with the normal equation, like the other one.
Yes. So
like before we derive it, do we use the equation first before we derive it? Then to get the second one, we have to derive it.
Correct. So what you are doing is that you are subbing x and y into f of x to get the first equation.
Yes.
Okay, so if you have a look over here, what we're doing, so this line in blue over here that I'm busy drawing now, I've taken these coordinates and I've subbed it into f of x, okay, in order to get that line over there. That's the first thing. Okay,
Yes,
then the second thing that we are doing is working with the derivative. So again, I'm going back here, but I'm working with the derivative. So I've applied my power rule. So I've gone 2 times a is 2a, and then I've taken the 1 away from the square, okay, to get 2ax. And then I've taken the 1 on the exponent on the x, and I've multiplied that by b to get the b, and then I've taken 1 away from the exponent. So I'm applying my power rule to these terms. Remember, the derivative of any constant is going to be 0. So that's why I only end up with 2 terms, even though I started with 3. And then I'm subbing in my gradient, which is my derivative at that point. And that is going to give me my second equation.
thank you. I think, the one I didn't know was the gradient of a tangent is equal to a derivative. That's where I always got stuck.
Oh, okay. All right. So I think me writing this over here for you, this helps a lot, doesn't it?
Yes.
Okay.
Yes.
So the gradient, the derivative of f with respect to x is the gradient of the tangent at that point. Okay, that is exactly the whole point. Okay, so I'm glad you can see that now. That's awesome. Faheen, I'm sure you can. Nelly will ask and we will let you guys know. Okay. Specifically, how to get an equation of the tangent if you are given f of x and a point. Okay, so specifically, what you would do in a situation like this, and I know that Nelly wants you guys to answer the poll, is x and y are connected in a special way with m, all right? And the way that it's connected is like this. They give you, I always draw this for my matrix. It makes sense to me. I don't know if it makes sense to other people. If they give you the x coordinate at the point of tangency, that really is the key to everything, all right? If they give you the x coordinate, then you can work out what the gradient is. Or you can sub back into the original equation and work out what the y is. Okay, but if they give you the gradient, you have to work backwards from the gradient to the x coordinate. Okay. And then only can you go and get the y. Okay, if they give you y, you have to work backwards to the x coordinate and then get the gradient. Okay, so again, you have to have a strategy for being able to answer these questions. This is the sort of stuff that you need to know so that you know what to do with the information that you've been given. Okay.
Okay, so